Hello, thank you for watching this video and studying your math with me. This is test prep, and so you should treat this as a work area. After I state a problem, you should pause the video, try to work it, and then advance the video to see a solution and ask questions as you have them. So here is an example of a first type problem that we have where you have to solve this, and as always we're going to get our expression equal to 0. So we will do this and we will put plus 5, and now that's equal to 0. But now we're going to have to use the quadratic formula because this will not factor when you try it. So a is 2, b is going to be equal to minus 10, and c is going to equal plus 5. So when we go through and do the calculation, then b squared is going to be 100 minus 4ac, which is going to be 40, and so that means we're going to have a square root of 60, and that is going to be plus or minus, and then it is minus b, so that is going to be 10, and then that is all over 4. Now when you plug this into a calculator, what will happen is, and I could ask you to plug this into a calculator, you will get 2 answers because one will be the plus and one will be the minus. And if I ask you to round it off, say to the nearest 10,000ths, you would get 2 answers. One would be 0.5635 and the other one would be 4.4365. So that is an example of one of the kind of problems that you'll see. A second kind of a problem, although there might be multiple versions of this, what I'm going to be asking you to do is, if I have a measurement, and here I'm using pi as the measurement, we're going to go through and figure out what the absolute error is, upper limit, so on and so forth. Now, the absolute error is going to be 1 less than the most significant digit showing, not 1 less, but the next place, and it's going to be 5. So it's 0.000 and 5. So that is the absolute error. The upper limit is going to be when I add that to this, so that is going to be 3.1415, and I could subtract also from that, and for the lower limit, so I would have 3.1405, and then I have the relative error. Now the relative error is found by taking the absolute error divided by the number itself, the measurement itself. And so here what you would get, and I do ask you to write this as a percentage, so this would be 0.0159, and that is percent. So you see that's really pretty accurate whenever you get that level of accuracy. So that is number 2. Let's look at a problem number 3. Now this is a problem where we're graphing the absolute values like we have talked about. This absolute value is going to open down, and after the absolute value opens down, you're able to say it's going to be shaped like a V, and the vertex is going to be 2, 5, and that means that the axis of symmetry is going to be x is equal to 2, and the x-intercept is found by setting y to be 0. If we set y to be 0, we will get this. I'll move that so we can see it. We put the 5 on the other side, so we're talking about the absolute value of x minus 2 equaling 5. So either x is going to be x minus 2 is going to be equal to 5, or it's going to be equal to minus 5. So what we're going to get actually is 2 x-intercepts, and they are going to be 7, 0, and the other one is going to be minus 3, 0. The y-intercept is found by letting x to be 0 in the original equation, and that's going to give us a minus 2, so that is going to be 0, 3, And then the last thing left is to graph it. Let's graph these points. quickly. So we're at 2, 5, so that's 1, 2. And we're up here to 5. We hit at 3. That is 0, 3. And we'll have the same thing over here. I hit at 7, 0. And at minus 3, 0. And so I will connect these dots with a V, and we will have a graph that looks like that. So that's how you would do problem number 3. Now there's a couple of problems. I'm calling them problems 4 and 5 that deal with direct and inverse variations as we study them. This one example contains them both. So we say Q varies directly as the square of R and inversely as W. Now that means, as we discussed in class, that Q is equal to K times R squared, and W is in the denominator. I also give you some data that allows you to figure out the constant of variation. And so when Q is 25, we have K is here, and let's see, and R is 100. And the W is 10, so that is 20. And so we say 5K is equal to 25. That tells us that K equal 5. K equal 5, there it is. And so we know that Q is equal to 5 R squared over W. But now we say what happens when R is 6 and W is 4. And we will substitute those in. We will have 5 R squared is 36 divided by W, which is 4, and that's going to be 9, and 4 times 5 is 45. So that's the answer to that problem. And we have both direct and inverse variation problems in the test itself. Next, we have a problem 6. And the problem 6, sometimes you can solve these quadratics by factoring. Here, what I would do is take this times this to get minus 60. So I'm looking for numbers that multiply to minus 60 but add to minus 7. And that's going to be filled, that bill is going to be filled by minus 12 and 5. The way we learned to do this then is we rewrite the middle term as 2 terms. That's going to be minus 12 x, and then it's going to be plus 5x, and it is minus 30. So now we're doing group factoring. We'll pull a 2x out of this, and left is x minus 6. And we'll pull a 5 out of this, and left is x minus 6. And so what we have then is 2x plus 5 times x minus 6 is equal to 0, and we set each of these in turn equal to 0, and that will yield solutions of x equaling 6 or x equaling minus 5 over 2. I'm breaking this into 2 pieces. The second half of this video deals with the balance of the test. There are going to be 12 questions.